Let's connect the standard normal distribution to a real-world example. Heights of adult males are normally distributed with a mean of 69 inches and a standard deviation of 2.8 inches. LeBron James is 6 foot 8 inches or 80 inches tall. Danny DeVito is 5 feet or 60 inches tall. Locate the heights of these two men on the standard normal scale. Okay, so we'll start with a drawing of our standard normal scale. And first let me note we have a mean of our population of 69 inches. And we're told the standard deviation of our population of men, 2.8 inches. Okay, got that information. I'll come down here and see if I can sketch my normal curve. Okay, peak in the middle, and on the standard normal curve the mean is 0, and then we know we come out 1 standard deviation, 2 standard deviations, 3 standard deviations. It does continue, but we said that the area is so tiny out here that it's not really practical to go beyond that. And below 1 standard deviation, below 2 standard deviations, and below 3. Okay, recall that we said that the area here is half of 1, or 0.5. So what that's telling us is that the probability of a randomly selected adult male, the probability that a randomly selected adult male is taller than our mean, 69 inches, is 0.5. So this is our mean, and now I'm going to put the inches underneath here. So for our real world problem, the mean is 69.0. On the standard normal scale, it's 0. Okay, here's our mean. So there's a 0.5 probability that a randomly selected male has a height above 69 inches, and there's also a 0.5 probability that a randomly selected male has a height below 0.5 inches. Okay, basically saying 50% of the adult male population is taller than 69 inches. 50% of the adult male population is shorter than 69 inches. Or we could even go so far to write our notation, the probability that x, which would be our height of a male, is greater than 69 is equal to 0.5. The probability that x is less than 69 is equal to 0.5. Okay, so we wanted to locate these two heights somewhere on our standard normal curve. So first let's just determine what we've got our normal curve, standard normal labeled, but now let's label it with the actual height value. So if I go 1 standard deviation above the mean, that means I go 69.0 inches plus 1 times 2.8, and that gives me 71.8 inches. So right here at the first standard deviation above the mean, that's 71.8. Okay, then I could go 69.0 plus 2 standard deviations above the mean, and 2 times 28 plus 69 is 74.6. So at 2, I'm at 74.6 inches. And then finally, we could go 3 standard deviations above the mean. 3 times 2.8 plus 69 is 80.2. So let's stop for a minute and label. So these values are z-scores, right? And my values on my horizontal scale for our for inches here, that's my X values, and those are labeled in inches. Okay, let's go the other direction. I'd have 69 minus 1 standard deviation, and that would get me to 66.2. So this value right here is 66.2. And then 16, whoops, I was going to use a different color there. 69 minus 2 standard deviations. And we get 63.4. And finally 69 minus 3 standard deviations. And we get 60.6. Okay, so we were asked to locate the heights of those two men on the standard normal curve. Where would they be relative to our average male right here? So let me see, I guess we can use this color. So we said LeBron James was 80 inches tall. So LeBron would be somewhere about right here, very close to almost 3 standard deviations right there. So I'm going to put LeBron. Okay, and we said Danny DeVito was 60 inches. 60, okay, 60 inches, here's 60.6, so he's below that even, right? He would be about right here maybe. So here's Danny. Okay, so we would say that LeBron is significantly taller than the average adult male. We could also ask ourselves, I wonder if his height is unusual. Likewise for Danny, he's significantly shorter than the average adult male. And our question would then be, is that unusual? Is his height unusual? Well, there's a couple of ways we can go about determining that. One is the range rule of thumb, where we calculate the maximum usual value and minimum usual value. So let's do that. I'll start with the minimum usual value, or minimum usual adult male height, is equal to the mean minus 2 standard deviations. Well, we saw what that was. Here's the mean, minus 2, 63.4 inches. And the max usual value or height for adult males would be the mean plus 2 standard deviations, and we saw where that was, 1, 2, we were at 74.6. So looking at this criteria, we could say that LeBron James at 80 inches is above the maximum usual height, so his height is unusual. And looking at Danny DeVito at 60 inches, which is below the minimum usual value, we would also conclude that his height is unusual. And recall, the empirical rule says that 95% of the data will lie between 2 standard deviations. So that's what we consider in here. From here to here, this area is 95%. So there's 5% left. 2.5 over here, 2.5 over here. And the usual values are in this 95% area. So again, we can see that Danny DeVito's height is below the usual value. LeBron James' height is above the usual value. So now we can get an understanding of how the z-scores work with our real world data and how they graph on the standard normal curve. Now be very careful to avoid confusion between z-scores and area. Z-scores are on this horizontal axis, along the horizontal axis on that scale. Remember, the probability or the area is the region under the curve, right? So you see how I'm labeling that from above with arrows. We don't put probabilities on the horizontal axis. Remember, these are our z-scores, or in our real world data, our x values.